Hello everyone, welcome to my YouTube channel. So today's video is very important because in today's video we are going to discuss about symmetric asymmetric keys and digital certificates, which are the foundation of distributed systems security. In the future I will be publishing more videos in which we will discuss different distributed system security concepts which are based on the concepts that we are going to discuss in this video. So suppose we have Alice and Bob. Alice is the wife, Bob is the husband. So Alice sends a message to Bob, "Can you send me your credit card number?" And Bob, being an obedient husband, will tell her the credit card number. And all this communication is, let's suppose, going over internet. They are using some messenger service, for example Facebook Messenger or WhatsApp. And now let's suppose there is a rat listening to this communication. Then he will be able to see what Alice is asking to Bob, and he will see that the Bob has sent a credit card number, which is this, to Alice, and he can use that credit card information to actually buy something for himself. And now because of this, Alice will be very angry because the money that she could have spent on her shopping has been used up by the rat. And Bob will also be very angry and sad because the money was gone, and it would have been better if the money was used by his wife and not by the rat. But unfortunately the rat used up all the money. So if Alice and Bob don't want any rat to sniff their communication, what they will do? They will actually use some encrypted communication mechanism. So when Alice will send a message to Bob, she will encrypt it using some password or passphrase or a key. And then when Bob will send message, that is the credit card number, to Alice, he will also encrypt that message with a password or passphrase or a key. So let's suppose there is a key K. So Alice knows that key and Bob knows that key, and maybe they can decide at home that okay, if they are going to send the messages to each other, they will use this key K to actually encrypt the messages. And then the other side, since other side will know the passphrase or the key, so they can use the same key then to decrypt the messages. So what will happen? Now Alice will actually send this message by encrypting it with this key. So what is happening now? That now Alice will actually use this key to encrypt the message, and this message will be encrypted, and then it will be some random string or something that even if the rat sees, he won't be able to decode it, that what is this message is. And Alice will send this message to Bob, and then at Bob's side, Bob will take this message and pass it through a decryption algorithm using the key to get the actual message. And the same way, when Bob will send the message back to Alice, he will use the same key to encrypt the message. And then when Alice will receive the message from Bob, she will use the same key to decrypt the message, and in that case they will be able to communicate this information securely without worrying about any rat sniffing all this information. So as you can see that the sender will actually encrypt the message using the key that the sender knows, and this message, when it's encrypted, it will be some random string or some random bits which does not make sense at all, and so the rat is unhappy because he cannot decode that message. And then when the receiver will receive this message, since he already knows the key, he will use the decrypt algorithm. He will input the encrypted message and the key to get the actual message. So this key K is called symmetric key because it is the same key which is used for both encrypting the message and decrypting the message. It is also sometimes called session key because whenever in a distributed system two parties communicate and they create a secure session to communicate, then they actually use this key to actually encrypt and decrypt the messages, and that's why it is also called a session key. So now the question is that let's suppose if these sender and receiver are actually two entities which are communicating over a network. For example, there could be a client app and a web server, and if they need to communicate with each other over a secure network, then they need some mechanism to actually exchange this key K with each other. So how they do that? Now let's discuss that. So in order to exchange the session key or the symmetric key, we actually use another type of keys which we called public private key pair. So let's suppose that Alice has a public private key pair which we are calling pub of A, which is the public key, and pri of A, which is the private key. So Alice has a public private key pair where public part is pub A and private part is pri A. Similarly, Bob also has a public private key pair. The public key of Bob is pub B and the private key of Bob is pri B. So as far as this private key is concerned, the private key of Alice is securely stored by Alice at some place so that no one else can have access to it. So this private key is secured. Similarly, the private key of Bob, which is this, it is also stored in a secure place which is only accessible by Bob. So what it means that only Alice knows Alice private key. Similarly, only Bob knows Bob private key. No one else in the world knows Alice private key except Alice. Similarly, no one else in the world knows Bob private key except Bob. Now Alice and Bob, they can publish their public keys to each other. So now Bob will know the public key of Alice and Alice will know the public key of Bob. Right now we are not going to detail that how Alice will determine whether this public key is actually the public key of Bob or not, or similarly how the Bob will determine that this public key pub A is actually the public key of Alice. We are skipping this part right now, but now let's assume that both Alice and Bob, they actually create their public private keys. The private keys are secured in a store place by the owner. So Alice stored her private key somewhere safe and Bob stored her private key somewhere safe, and then both Alice and Bob, they exchange their public keys, or they publish their public keys, and actually this public key is public. Now how this public private key is used? There are 4 different things that can be done with this public private key pair. So the first thing is encrypt a message. The second thing is decrypt a message. Then the third thing is sign a message. And then the fourth thing is verify the message. So this encrypt and decrypt is a pair and sign and verification is a pair. What does it mean? So in order to encrypt a message using a public private key pair, you need the public part to encrypt a message. So this is done using the public key. The decryption only happens with the private key. Similarly, the signing process is only done with the private key, and the verification can only be done by the public key. So now let's discuss them in detail. So very first thing, as I said, in the public private key pair, the encryption is only done using the public key. So now if Alice needs to send a message to Bob, Alice will use Bob public key to encrypt a message. And now this encrypted message can only be decrypted using the private key of Bob. And since only Bob knows his private key, so no one else except Bob can actually decrypt that message. And that is why if Alice needs to send a message to Bob, Alice will use Bob's public key to encrypt the message, and then when Bob will receive this encrypted message, he will use his private key to decrypt it. Similarly, if Bob needs to send a message to Alice, Bob will use public key of Alice to encrypt the message and send that encrypted message to Alice, and then Alice will use her private key to actually decrypt it. And so while they are communicating, if there is a hacker or a rat which is listening to those messages, he will not be able to decrypt those messages because he does not have the private keys. So now usually how the session keys or the symmetric keys are exchanged is that there's a handshake, and in the handshake one of the party actually decide a key or generate a session key, and then it uses the other's party public key to encrypt that key and send it to the other party. For example, the Alice and Bob can actually do some handshake, and then Alice, for example, can decide some session key K, and then she can actually use public key of Bob to actually encrypt that key and send it to Bob. And since Bob is the only one who can decrypt that message using his private key, he will be able to decrypt it, and then he will know what is the session key which Alice wants him to use while communicating over the public network. So that's how the public and private keys are used to actually exchange session keys. And now this type of public and private keys, they are called asymmetric keys as compared to the previous symmetric key scenario, because in the previous case there was a single key which was used both for encryption and decryption, and that's why it was called the symmetric key. But public private key pair is called asymmetric keys because we use public key to encrypt the message and then private key to decrypt it. Similarly, these public and private keys are used for signing and verification. For example, if Alice says that I am 21 years old and she signed this message with Alice's private key, and when she signed it with Alice's private key, the output is a digital signature, which is nothing but just a hash, and that hash she can send along with this message to Bob. And now Bob needs to validate whether this message is from Alice or not, and in that case what he will do, he will use the public key of Alice to actually verify this message along with the hash that was sent with this message. And if the verification is successful, then it means that this message was indeed sent by Alice. Let's see it again one more time. So what happens, let's say if Alice wants to send a message to Bob and Alice wants to tell Bob that the message is from Alice. So what she will do, she will use the message and her private key, and she will sign the message with the private key to generate a signature. This signature will be a hash. It could be a 128-bit hash, 192-bit hash, or 256-bit hash. And then Alice will send this message along with this signature to Bob. And then Bob will actually pass this signature, the message, and the public key of Alice to a verification process or algorithm to verify whether this message is actually indeed generated by Alice or not. And the result could be either true or false in that case. Normally, how the verification process works is that it actually takes the public key and the signature and it decrypts the signature using the public key to get another hash, and then it compares the hash with the hash of this message that was passed. And if the hash matches, it means the message is indeed from Alice. And if somehow the message, if the hash doesn't match, it means the message was either changed while transmission, or maybe the public key is not the right pair for the private key with which the message was signed. These public and private keys are then used for generating digital certificates. So what is a certificate? A certificate is nothing but just a document which is signed by the private key of the sender. And so anyone who has the public key of the sender can actually validate that this is a certificate which is generated by the signing authority or the signer. So now let's go to the problem where how these public keys will be exchanged in a way that each party can actually assume that the public key that they are seeing for the other party is the right key. For example, when Alice sent his public key pub A to Bob over the network, this is internet, she sent it over the internet, how Bob will know that the public key that he is receiving is indeed from Alice? It's totally possible that there's an hacker in between which actually can switch the public keys. So in order to tackle this scenario, we use digital certificates. So now let's assume there's already some person, think software, who both Alice and Bob trust. Let's just assume it. And this think software also has his public key, pub_ts, and private key, private_ts. And both Alice and Bob, they know public key of think software. So they already know public key of TS somehow. So now Alice wants to send her public key to Bob. Alice will go to the think software and Alice will tell think software, hey, you know me, so can you give me a certificate that I am trustful, and this is my public key that you can attach to it. So she gave her public key to think software. Think software, since already know about Alice, he will generate a certificate, a cert, which says Alice is trustful, and also it has pub of A in it, in this certificate. So now Alice will keep this with her. Similarly, the same thing will happen for Bob as well. Bob will also get a certificate from Think Software, because Think Software also knows Bob, and so he also get a certificate from Think Software saying Bob is trustful along with Bob public key. So now when these two, Alice and Bob, need to exchange their keys, Alice will simply send this certificate that she got from Think Software to Bob, and similarly Bob will send the certificate that he got from Think Software over the network to Alice. And so when Bob will receive the certificate that Alice sent, so he will see in the certificate that Alice is trustful and this is the public key of Alice. Since this certificate is signed by Think Software and he trusts Think Software, so he first try to validate whether this certificate is indeed signed by Think Software or not. So Bob will use the public key of Think Software to validate. And once the certificate is validated, then he will know, okay, Alice is trustful and this is the public key of A that he can use to actually send any encrypted message, and same goes the other way around as well. So in this scenario, this Think Software is called a certificate authority or CA. This certificate authority or CA is something that is already known and verified by the parties. And now let's see how this scenario is get applied for our distributed systems, especially when a client app communicates with a web server. Now consider a scenario where we have a client browser, for example Chrome, and the Chrome browser wants to communicate with a web server, and there is some certificate authority. When you install a browser, like for example Chrome, the installation process also install some certificates from a certificate authority as well. Similarly, now this web server will get a certificate from the certificate authority saying that this web server is trustful, and this web server will also give a public key to this certificate authority, and when the certificate authority will generate the certificate, it will also embed that public key also in that certificate. So now what happens is that this web server will actually give the private key pub of web server to the certificate authority, and the certificate authority will actually generate a certificate which embeds that public key of the web server, and also it will say that this web server is trustful, and it will send that certificate to the web server. And so now when the client browser makes a connection first, and of course we will go to a detail of how this secure connection works, but in a very simplified form, what actually happens is that when the client browser makes a connection, the web server actually passes that certificate to the client browser. The client browser already have stored some certificate like public key of the certificate authority here. This is already here. It has the public key of CA, and when the client browser receives that certificate, then it uses the public key of the certificate authority to validate whether the certificate is indeed signed by the CA or not. And if it is signed by CA, since the browser trusts CA, it will also now trust this web server, and then it will actually use the public key that is embedded in the certificate that it received from the web server to actually encrypt a message and send it to the web server. So I'm going to stop the video here. I hope you find this information useful. If you're interested to know about how the mathematics is performed for the symmetric and asymmetric keys, let me know in the comments below. Then I will make a separate video for the mathematics and also different types of algorithms that we use for the symmetric and asymmetric keys. And of course, I will really appreciate if you like my videos because it actually, I don't know whether it has any effect or not, but what it seems like, if you like the video, then actually it has some positive effect on the YouTube algorithm. So I would really appreciate if you like my videos, and please, and if you haven't subscribed to my channel yet, what are you waiting for? Please subscribe to my channel. There will be more videos coming. Take care and bye.